Tonight, we begin with a quiet question. A question asked in ordinary conversation, but large enough to stretch across the universe. Where is everybody? The question is simple. The implications are not. It was asked in 1950 by the physicist Enrico Fermi during a casual lunch discussion, not in an observatory, not during a formal lecture, just among colleagues. Yet the question stayed alive. It became known as the Fermi Paradox. To understand why it feels like a paradox, we begin with scale. Very large scale. Our home is the Milky Way galaxy, a spiral galaxy containing perhaps 100 billion stars. Some estimates suggest even more, hundreds of billions perhaps. Around many of those stars, planets orbit. For most of human history, this was speculation. Today it is observation. Astronomers have confirmed thousands of exoplanets, worlds circling other suns. Some large, some rocky, some in regions where liquid water may exist. Already, this changes perspective. Our solar system does not seem unusual for having planets. Planetary systems may be common, very common. And if stars are numerous, and planets are numerous, and some fraction may be habitable, then one thought arises naturally. Could life have appeared elsewhere? Notice how modest that question is. Not intelligent life, not advanced civilizations, simply life. Even microbial life would matter. Life on Earth appeared surprisingly early. The Earth formed about 4.5 billion years ago. Evidence suggests simple life emerged within perhaps a billion years, possibly sooner. On geological timescales, that may be relatively quick. Some see this as a hint. Perhaps, when conditions permit, life may arise readily. That remains uncertain, but it is part of the reasoning. Then comes another thought. If life can emerge, perhaps sometimes it evolves complexity, perhaps sometimes intelligence, and very occasionally technology. Now the quiet question grows larger. If the galaxy has had billions of years and billions of possible worlds, why do we see no obvious sign of others? This is the heart of the paradox. Not proof that aliens exist, not proof they do not, but tension between expectation and observation. Expectation says there may be many opportunities for life. Observation says we notice silence. A great silence. Sometimes this is called the Great Silence. A poetic phrase, but also descriptive. No clear signals. No confirmed visitors. No visible galactic engineering. At least, none recognized. This can feel strange because the galaxy is old. Very old. The Milky Way is over 13 billion years old. Earth is much younger. Human civilization younger still. Agriculture is about 10,000 years old. Radio technology little more than a century old. In cosmic terms, These are moments. If another civilization began even 1 million years before us, it would have an unimaginable head start. 1 million years is enormous to us, but small compared with galactic history. This is where many people feel the puzzle deepen. With so much time available, why no obvious presence? Yet the paradox is not a contradiction in strict logic. It is better understood as a problem, a scientific puzzle, a mismatch inviting explanation. Perhaps intelligent life is rare. Perhaps civilizations do not last long. Perhaps we are searching poorly. Perhaps the silence only seems strange because our assumptions are incomplete. All these possibilities come later. For now, we remain with the question itself. It helps to imagine the night sky. Thousands of visible stars from dark places, each perhaps with worlds, yet quiet. Human beings have often looked upward and wondered whether we are alone. Ancient cultures asked it in myth. Modern science asks it through astronomy. The longing is old. But modern astronomy changed the scale of the question. It became less abstract, more quantitative. We could begin estimating possibilities. And this is important. The Fermi Paradox does not arise from fantasy. It arises partly from numbers. Very large numbers. Consider travel in the galaxy. Even without faster-than-light ideas, stars are separated by distances that advanced technologies might slowly cross. Not quickly, but over millions of years perhaps. Again, the question returns. If this seems possible, why no traces? It circles back, quietly, repeatedly. That repetition is part of why the paradox endures. There is also humility in this question. We should be careful not to assume too much. We have sampled only one world known to host life. Earth may be typical or unusual. We do not yet know. Much of astrobiology lives inside that uncertainty. Some misunderstand the paradox as evidence aliens must exist. That is too strong. Others take the silence as evidence they do not exist. That too is too strong. The paradox proves neither. It simply sharpens a question. Why does a universe that seems potentially fertile appear so quiet? There is another layer. We are beginners in this search. Radio searches have sampled only tiny fractions of possible frequencies and sky regions. Techno-signature searches are still young. So silence may partly reflect limited listening. If you dip a cup into the ocean and find no whales, you have not surveyed the sea. This caution matters. The paradox should invite thought, not certainty. Yet even with caution, the question remains compelling. Because it sits at the meeting point of astronomy, biology, probability, and philosophy. Few questions touch all these at once. It asks about other minds, but also about our own future. If civilizations often disappear, what does that imply? If intelligence is rare, what responsibility follows? Even before answers, the question changes perspective. It can make Earth feel small and precious. Sometimes the paradox is framed too dramatically, as if the silence itself were frightening. But silence need not be ominous. It may simply be unsolved. Science often begins there, with something not yet understood. And perhaps that is why this simple lunch table question survived decades. Because it is easy to state, difficult to exhaust. Where is everybody? The question echoes because every possible answer opens another question. Maybe there are many civilizations. Then why hidden? Maybe there are few. Then why so few? Maybe only us. Then why only us? Each answer loops back, quietly, like an orbit. Before moving deeper, hold one simple image. A galaxy full of stars, ancient beyond comprehension. Planets likely scattered in enormous number. And amid all this possibility, apparent silence. That is the starting point. Not a conclusion, a beginning. From here, a natural next step is to ask why scientists ever expected a crowded cosmos at all. If the universe seems quiet, why did many scientists ever expect it might be full of life? The expectation did not arise from fantasy. It arose gradually, from astronomy, from biology, from probability. It began with a simple observation. The ingredients of life do not appear unique to Earth. Carbon is common. Hydrogen is abundant. Oxygen is widespread. Nitrogen is common. Many of the chemical building blocks associated with life exist across the cosmos. Astronomers have detected organic molecules in interstellar clouds. Some are simple, some more complex. Even before planets were discovered around other stars, this suggested life's raw materials may not be rare. Then there are stars themselves. There are so many. This point returns often because it matters. There are so many stars. If a galaxy contains perhaps 100 billion stars, even rare events may happen many times. This is basic probabilistic thinking. Suppose only a tiny fraction of stars host planets where life could arise. A tiny fraction of a huge number may still be a large number. This reasoning encouraged optimism. Not certainty, but optimism. For much of the 20th century, however, one major unknown remained. Did other stars even have planets? People suspected they did, but suspicion is not observation. Then came evidence. In the 1990s, astronomers began confirming exoplanets, planets beyond our solar system. This was a major turning point. It changed the discussion from speculation into measurement. Over time, discoveries multiplied. Hundreds, then thousands. Some gas giants, some rocky worlds, some in systems unlike ours, some surprisingly familiar. One mission in particular shifted thinking dramatically. The Kepler Space Telescope helped reveal that planets may be common rather than exceptional. That was profound. It suggested our solar system may not be a cosmic oddity. Then came another idea: the habitable zone, sometimes called the Goldilocks zone. Not too hot, not too cold. Conditions where liquid water might exist at a planet's surface. Water matters because life on Earth depends on it. We should be cautious. Life elsewhere might differ, but water remains a reasonable starting point. So when astronomers found rocky planets in habitable zones, interest deepened. Perhaps some worlds might be temperate. Perhaps some oceans exist elsewhere. Again, the pattern repeats. Large numbers, many planets, some potentially suitable. The expectation of life begins to seem less strange. Yet optimism was shaped by biology too. Life on Earth shows resilience. It survives in deserts, in ice, near deep-sea vents, in acidic conditions once thought hostile. Extremophiles expanded imagination. They suggested life may tolerate wider conditions than once assumed. If life can persist in unexpected places here, perhaps habitable environments elsewhere may also be broader than first believed. This did not prove extraterrestrial life, but it softened assumptions of rarity. Then there is time. Time is often overlooked, but it is central. The universe is old, very old. Given enough time, even unlikely events may occur repeatedly. This too fed expectation. Notice how modest much of this reasoning is. It does not claim galaxies teeming with star empires. It only suggests life may not be absurdly improbable. But over time, optimism extended beyond simple life. Some wondered whether intelligence might also emerge elsewhere. On Earth, intelligence evolved through natural processes. No special cosmic intervention appears required. So some reasoned it could happen again. Of course, this step is more uncertain. Intelligence may be rare. It may depend on contingent events. But it was enough to raise the possibility. And once technological civilizations are considered, a deeper expectation appears. If even a few civilizations arise and endure, perhaps they leave detectable traces. This is where optimism and paradox begin to meet. Because the same reasoning that makes extraterrestrial intelligence seem plausible can make silence feel puzzling. There was also cultural optimism in the 20th century. Science and technology were advancing rapidly. Radio, spaceflight, computing. Some imagined progress as universal. If we could invent radio within a few centuries of modern science, perhaps others might too. This encouraged projects searching for signals. Most famously, efforts linked to SETI, the search for extraterrestrial intelligence. The logic was simple. If technological societies exist, perhaps some emit detectable radio signals. Perhaps intentionally, perhaps accidentally. Even the act of listening reflected expectation. You do not search unless you think something may be there. But there was another, more formal expression of this optimism. The attempt to estimate communicating civilizations. This led to the famous equation associated with Frank Drake. We will explore that equation slowly later. For now, only notice its spirit. It broke a giant mystery into smaller questions. How many stars form? How many have planets? How many could support life? How often does intelligence arise? It was not a machine for certainty. It was a framework for thinking. And its very existence reflected optimism that the question was scientifically approachable. There is something gentle in that. Not claiming answers, simply asking whether the cosmos might be populated. Some arguments were even simpler. They said, if Earth happened once, why not elsewhere? This argument can be too loose. One example does not establish frequency. Yet psychologically, it mattered. It made people resist assuming human uniqueness by default. Another factor was the Copernican instinct. The idea that humans often overestimate their centrality. Earth is not the center of the solar system. The Sun is not the center of the galaxy. Our galaxy is not central in the universe. So some extended this pattern. Perhaps life on Earth is not uniquely privileged either. This is sometimes called a mediocrity principle. Not meaning mediocre in quality, only statistically ordinary. If Earth is in some respects ordinary, then life elsewhere may seem plausible. Again, not proof, but expectation. Yet it is important to notice something often missed. Expecting life somewhere is not the same as expecting nearby civilizations. Those are different claims. One may be true, while the other is false. There may be microbial life widespread, while intelligent technological life remains rare. This distinction matters deeply in the Fermi Paradox, because much of the paradox concerns advanced civilizations, not merely biology. Still, optimism about simple life often fed optimism about more. Step by step, quietly, it began to seem possible the galaxy could be inhabited in some broad sense. And then comes the tension. If these expectations are reasonable, why no clear evidence? That tension gives the paradox force. Without expectation, there is no paradox, only silence. This is why understanding the optimism matters. It is half the puzzle. But even this optimism should be held gently. There are counter-arguments. Maybe abiogenesis is fantastically rare. Maybe intelligence is a fluke. Maybe technological societies vanish quickly. Those possibilities remain open. Science has not resolved them. Yet the expectation of a crowded cosmos did not emerge carelessly. It emerged from observed abundance, chemical abundance, stellar abundance, planetary abundance, temporal abundance. Over and over, abundance suggested possibility, and possibility invited wonder. Imagine standing beneath a clear sky again, looking at countless stars, knowing many may host planets, knowing some may be ancient beyond imagination. It becomes natural to ask whether some harbor life, natural to ask whether some developed intelligence, natural even to expect company. And this is why the silence can feel surprising. Not because we know the galaxy is inhabited, but because there seem to be so many opportunities for it to be. Opportunity. That is the quiet key. So many opportunities. In the next layer of thought, those opportunities were given mathematical form, slowly assembled into one of the most famous equations in astronomy. We can take the vast question of cosmic life and break it into smaller questions. That was the quiet brilliance of the equation associated with Frank Drake. It did not claim certainty. It did not solve the mystery. It organized uncertainty. In 1961, Drake proposed a framework for estimating the number of civilizations in our galaxy that might be detectable through communication. Not all intelligent life. Not all civilizations. Specifically, civilizations capable of emitting signals we might notice. This distinction matters. The equation concerns communicative technological societies. It is often written as a chain of factors multiplied together. Each factor narrows the possibilities. Step by step, quietly. At its broadest, it begins with stars. How many suitable stars form in the galaxy? This first factor concerns star formation rate. New stars are born from clouds of gas and dust. This has been happening for billions of years. The exact rate changes over cosmic time. But the question is simple. How many stars are there to begin with, entering the pool of possibility? Already, we begin with abundance. Many stars. Then the next question. Of those stars, how many have planets? When Drake proposed the equation, this was deeply uncertain. Today, evidence suggests planetary systems may be common. This term may be larger than early astronomers imagined. Many stars may host worlds. But not all planets are equal for life as we understand it. So comes another factor. How many of those planets could support life? Notice the gentle narrowing. Stars. Then stars with planets. Then planets potentially suitable. This term is difficult. What does suitable mean? Surface water? Stable climate? Necessary chemistry? We do not know all requirements. That uncertainty matters. The equation does not hide uncertainty. It displays it. Then comes one of the deepest unknowns. Unsuitable worlds, how often does life actually appear? This is profound because we have only one confirmed example: Earth. With one example, estimating frequency is hard, very hard. Some suspect life emerges readily where conditions allow. Others suspect it may be extraordinarily rare. We do not yet know. The equation leaves room for both possibilities. Then another narrowing. On worlds where life begins, how often does intelligence arise? This is not the same as life itself. Microbial life may be common, while intelligence is scarce. On Earth, life existed for billions of years before technological intelligence appeared. That fact invites reflection. Intelligence may not be inevitable, or perhaps it is favored under some conditions. Again, uncertainty. Again, the equation makes uncertainty visible. Then comes technology. Of intelligent species, how many develop detectable technology? This too is not automatic. Intelligence does not guarantee radio telescopes. A species may be intelligent, but not technological in ways we recognize. Or technological in forms beyond our assumptions. And even if technology arises, another question remains. How long do communicative civilizations last? This final term may be the most haunting. Longevity. A civilization may arise, emit signals briefly, and vanish. If such windows are short, overlap between civilizations may be rare. This matters enormously. Even if civilizations arise often, short lifetimes could make the galaxy seem silent. This is one reason the equation connects so closely to the Fermi Paradox. The silence may reflect not absence, but timing. We may simply be listening in a vast night where few windows overlap. Notice something elegant here. The equation is not one claim. It is many questions braided together. Each factor can be debated separately, refined separately, measured sometimes separately. That is why many scientists value it. Not because it produces one definitive number, but because it structures discussion. It turns a mystery into components. That is often how science proceeds. Sometimes people ask, what number does the equation give? But there is no single answer. Different assumptions produce very different results. Optimistic assumptions may suggest many civilizations. Pessimistic assumptions may suggest very few. This wide range is not failure. It reflects genuine unknowns. Consider one uncertain factor, changing slightly. If life emerges on 1 in 10 suitable worlds, outcomes differ greatly from 1 in a million. Small assumptions can ripple enormously. This sensitivity teaches humility. The equation can be read almost as a map of ignorance. Here is what we know a little about. Here is what we know almost nothing about. For example, astronomy has improved estimates for stars and planets. Those early terms have become somewhat firmer. But later terms involving life, intelligence, and longevity remain deeply uncertain. They belong partly to biology, evolution, even sociology. This is one reason the equation is so fascinating. It links many fields: astronomy, biology, evolution, technology. A single question touches them all. There is also a subtle lesson. Large numbers at the beginning do not guarantee large numbers at the end. Multiplication can shrink quickly, very quickly. Billions of stars may narrow to millions of suitable planets. Then perhaps fewer with life, fewer still with intelligence, fewer with enduring communication. Suddenly, abundance can become rarity. This is why the equation can support both optimism and caution. It does not force one worldview. Some even use it philosophically. If longevity is decisive, perhaps the deepest question is not how civilizations arise, but how they endure. That thought will return later, quietly. Another important clarification. The Drake equation is not a law of nature. It is not like gravity. It is a heuristic framework, a way to reason. That makes it flexible, but also vulnerable to misuse. Sometimes people treat one speculative calculation as fact. Better to see it as structured thought experiment. There is something calming in that. It invites contemplation rather than dogma. Some modern researchers revise the framework. They add uncertainties more formally, use probability distributions rather than single guesses. This reflects progress. The spirit remains the same. Break the mystery into questions. And perhaps that is its deepest contribution. It teaches how to think about immense unknowns, not by staring only at the whole, but by examining parts. A galaxy can feel overwhelming, but one factor at a time feels approachable. How many stars? How many planets? How often life? How often minds? The repetition itself has rhythm, almost like counting. And still, after all this, the great uncertainty remains. We do not yet know whether communicative civilizations are many, few, or only one. The equation does not answer. It prepares the question. Yet even preparation changes perspective. Because once one begins multiplying these possibilities, one naturally wonders about consequences. If civilizations can arise, could they spread? If they could spread, should evidence exist? Here, the Drake equation begins leaning toward another puzzle. Not just whether others exist, but if they do, why no visible traces? That returns us toward the core of the Fermi Paradox. The paradox grows sharper once possibility has been quantified. And from there, another question emerges naturally. If even slow interstellar expansion were possible, would a galaxy eventually show signs of presence? That is where the mystery deepens further. For a long time, one approach to the mystery focused on listening. If civilizations exist, perhaps they may be found through signals. Not starships arriving, not dramatic encounters, but quiet evidence carried by physics. This is the spirit behind the search for extraterrestrial intelligence, often called SETI. The idea is simple. If intelligent civilizations use technology, perhaps some technologies produce detectable traces. And if those traces travel through space, perhaps they may one day be noticed. This approach does not begin by assuming contact. It begins by asking what evidence might exist. Evidence before encounter. One early turning point came in 1959. Physicists Giuseppe Cocconi and Philip Morrison proposed that radio might be a promising medium for interstellar communication. Radio waves can travel enormous distances. Some frequencies pass through interstellar space relatively well. This made a practical thought possible. Perhaps civilizations might use radio beacons. Or perhaps ordinary technological activity might leak radio signals into space. Soon after came Project Ozma. In 1960, astronomer Frank Drake used a radio telescope to listen toward nearby sun-like stars. It found no confirmed signals, but something important began. A scientific search. Not fantasy. Method. Over time, this became broader. Many radio searches followed. Different telescopes, different frequency ranges, different strategies. Some searched for narrowband signals. Signals concentrated in very small frequency ranges. Such signals can be interesting because many natural sources tend to be broader, though nature can surprise. Always caution. There was also discussion of a special region called the water hole, a radio band between spectral lines associated with hydrogen and hydroxyl. Since hydrogen and OH relate to water, some imagined this region as a quiet natural channel civilizations might choose. Whether or not that assumption holds, it shows how practical reasoning entered the search. Listen where logic suggests listening. Yet decades passed without confirmed extraterrestrial signals. Which brings a subtle question. Does silence in SETI strengthen the Fermi Paradox? In part, yes, but only cautiously. Because absence of detection is not the same as proof of absence. That distinction matters enormously. We have searched only a tiny fraction of possible signal space. A tiny fraction of sky positions, frequencies, time windows. The search has been narrow compared with the size of the problem. Some researchers have compared it to sampling a glass of water from the ocean and concluding no fish exist. An imperfect analogy, but instructive. Silence may reflect emptiness or insufficient listening. This ambiguity sits at the heart of the paradox. There have also been moments of intrigue. In 1977, the famous "wow" signal was detected. A strong narrowband radio signal. Brief. Unrepeated. Its discoverer famously wrote, "Wow," beside the data. For decades it stirred imagination. Yet it has never been confirmed as extraterrestrial intelligence. It remains an anomaly. Interesting, unresolved, but not evidence of contact. This restraint is important. Science advances by resisting premature conclusions, especially with extraordinary claims. In recent decades, the search has widened beyond classic radio SETI. Scientists increasingly discuss technosignatures, a broader concept, not only messages, signs of technology. A civilization might be detectable without trying to communicate. For example, some have proposed searching for unusual infrared waste heat. If immense energy harvesting structures existed, perhaps thermodynamic signatures might appear. These ideas are speculative, but scientifically framed. Again, the question is practical. If intelligence alters environments, could astronomy detect those alterations? This includes possible atmospheric technosignatures too. Industrial gases, artificial chemical imbalances. Still theoretical, but increasingly discussed. Notice something beautiful here. The search evolves as knowledge evolves. Better telescopes, broader concepts, new methods. The silence has not ended inquiry. It has refined it. There is patience in that. It is also worth noticing how SETI relates to the Fermi Paradox. SETI is not itself an explanation of the paradox. It is partly a response to it, a way of investigating the question empirically. Instead of asking only philosophically where everybody is, we listen. We search. That matters. It transforms paradox into research program. Yet listening also exposes assumptions. We often assume civilizations would broadcast. But why assume that? Perhaps they communicate differently. Perhaps they do not signal outward at all. Perhaps detectable phases are brief. These possibilities complicate interpretation. A silent sky may not be an empty sky. There is also the question of time overlap again. Civilizations may arise separated by millions of years. Two technological societies may rarely coexist in communicative overlap, even if many have existed. Timing may erase conversation. The Drake equation hinted at this. Here it returns in practical form. Longevity matters. Some have suggested the paradox may partly reduce to a longevity problem. Not whether civilizations arise, whether they last. This thought leads toward another major idea we will soon reach. But before that, there is something almost philosophical in SETI itself. It is an experiment in cosmic humility. We build instruments, then wait. Quietly. Listening as method. There is something fitting in that for this mystery. Because the paradox itself emerged from listening to silence. Some critics have argued resources devoted to SETI are uncertain bets. Others argue even low-probability searches can be justified by enormous significance. Both perspectives exist. Serious people hold both. Yet the field continues. Quietly persistent. And perhaps persistence is appropriate for a question measured in cosmic scales. There is a deeper lesson here, too. Sometimes science advances not by solving a mystery immediately, but by clarifying how hard the mystery is. SETI has done some of that. It has not answered where everybody is, but it has made the question sharper. And sharpening a question can be progress. Especially in frontier science. There is also beauty in how modest the evidence standard remains. Extraordinary claim, extraordinary evidence. This discipline matters. Without it, mystery becomes mythology. With it, mystery remains science. And perhaps that is part of why the Fermi Paradox has endured respectably. It invites wonder without abandoning rigor. Still, after decades of listening, one difficult thought grows stronger. What if silence is telling us something not about signals, but about survival? What if civilizations often do emerge, but rarely pass some critical threshold? That possibility leads toward one of the most haunting ideas in the whole paradox. The possibility of a great filter. One possible answer to the silence of the universe is very simple. Perhaps life is not common at all. Or perhaps simple life may exist widely, while complex life is rare. Very rare. This idea is often called the rare Earth hypothesis, associated especially with Peter Ward and Donald Brownlee. Wikipedia 1. The idea does not necessarily say life is unique to Earth. It makes a narrower claim. That complex intelligent life may require an unusual chain of conditions. Conditions that may seldom come together. At first, this may sound surprising. We have spoken of abundance. So many stars, so many planets. Why should life be rare? The argument begins by separating simple life from complex life. This distinction matters deeply. A world with microbes is not the same as a world with forests, or animals, or civilizations. One may be much easier than the other. On Earth, life appeared early. But complex multicellular life came much later. For billions of years, Earth was mostly microbial. Tiny cells, oceans of microscopic life. That long delay raises a quiet question. Was complexity hard to achieve? Some think perhaps yes. Perhaps simple life may emerge often, but complexity may face bottlenecks. Evolutionary bottlenecks. Rare transitions. Consider one example often discussed: the emergence of eukaryotic cells. Cells with internal structures, more elaborate organization. All plants, animals, and fungi depend on this leap. Yet it may have happened only once in Earth's history, as far as we know. Wikipedia 1. If such transitions are exceptionally rare, many living worlds might remain microbial forever. That alone would change the cosmic picture. Then there is multicellularity, another possible hurdle. Then nervous systems, then intelligence, then technology. A chain of difficult steps. The rare Earth idea asks whether too many unlikely steps may be required. But biology is only part of it. The hypothesis also looks at planetary conditions. Earth may seem ordinary because we live here, but perhaps some features are unusually favorable. Consider our star. The Sun is relatively stable. Its long-lived steadiness may matter for complex evolution. A more violent star might bathe the planet in harsher radiation. Then consider Earth's orbit. It remains relatively stable over long periods. Stability may matter. Evolution often works slowly. A planet with constant extreme disruption may struggle to sustain complex ecosystems. Some point to plate tectonics, the shifting of Earth's crust. It helps recycle carbon, influences climate over deep time, shapes continents and oceans. Some argue such geologic regulation may be important for long-term habitability. Though scientists debate how unique or necessary this is, Wikipedia 1. Then there is Earth's magnetic field. It helps shield the planet from charged solar particles. Perhaps important, perhaps not decisive, but often included in these discussions. Another famous example is the Moon. Earth has a large moon relative to its size. Some have suggested it may help stabilize Earth's axial tilt, which may support climatic stability. Again, debated, but part of the argument. There is even discussion of giant outer planets, worlds like Jupiter, sometimes imagined as partial shields, perturbing or intercepting some impact threats. Though this too is more nuanced than early simple versions suggested. The larger point is not any single factor. It is accumulation. Many conditions, many contingencies, many possible filters. Perhaps each alone is modestly uncommon, but together, perhaps extremely rare. Multiplication again, like the Drake equation, but in reverse spirit. Not abundance narrowing to mystery, but rarity emerging from stacked conditions. There is also the role of contingency in evolution. History may matter more than law. Consider mass extinctions. Earth has suffered several. One famous event ended the age of non-avian dinosaurs. 66 million years ago. Some argue without that event, mammals may not have diversified as they did, and humans may not appear. If true, intelligence may depend partly on accidents. Cosmic accidents. A struck asteroid. A changed climate. A different branch surviving. This makes the path feel fragile. Some extend this to the Cambrian explosion. The great diversification of animal life. Though not an instantaneous explosion, despite the name, more a broad evolutionary radiation over millions of years, PMC-2. Still, it raises questions about conditions needed for complexity. Perhaps many worlds remain biologically simple, quietly alive, but never developing civilizations. If so, the Fermi Paradox softens. Maybe there is no crowd to notice. The silence would no longer be mysterious, only expected. This is why rare earth is sometimes presented as one solution to the paradox. We do not hear others because others are exceedingly few. But caution matters here. This is a hypothesis, not established fact. Many scientists question parts of it. Some argue it may underestimate life's adaptability. Others note we have only one biosphere to study. From one example, confidence should be modest. That humility is important. Rare earth may be right, or partly right, or too pessimistic. We do not yet know. There is another subtle criticism. Sometimes conditions described as necessary may only be conditions familiar to us. Life elsewhere may surprise us. Biology may find roots we have not imagined. Science has been surprised before. Often. Still, even critics often grant a softer point. Complex life may indeed be much rarer than simple life. That alone could matter enormously. There is a quiet emotional shift in this idea. It makes Earth feel less typical. Not central, but perhaps precious. A world balanced through many contingencies. Oceans, atmosphere, geology, time, and perhaps improbable fortune. Whether or not the hypothesis is fully correct, it invites appreciation of complexity. Life is not just chemistry. It is chemistry sustained, evolving, stabilized through ages. That may be harder than it first appears. Sometimes the hypothesis is misunderstood as saying humans are special by destiny. That is not its scientific meaning. It concerns probabilities, not purpose. Contingencies, not cosmic favor. That distinction matters. There is something almost paradoxical here. The more we learn how intricate Earth's story is, the more plausible rarity can seem. Yet the more we learn how adaptable life can be, the more plausibly abundance returns. Two intuitions in tension, both alive. That is often where science rests before evidence resolves more. For now, rare earth remains one answer among many. A sober answer. A quiet answer. Maybe the galaxy is not full of civilizations because complex life itself is uncommon. But another possibility turns the question in a darker direction. Perhaps life is not rare at the beginning. Perhaps many civilizations arise. But few survive some great bottleneck. There is another way to understand the silence. Perhaps life is not rare at the beginning. Perhaps the difficulty comes later. Much later. This is the idea known as the Great Filter, a hypothesis often associated with Robin Hanson, Wikipedia 1. The idea is simple in form, but unsettling in implication. Somewhere on the path from dead matter to advanced interstellar civilization, there may be an extremely difficult step. A bottleneck, a filter. Something most worlds do not pass. Imagine a long sequence. A planet forms. Life begins. Complex cells emerge. Intelligence evolves. Technology develops. Civilizations endure. Some may expand into space. The Great Filter says at least one step in that chain may be extraordinarily improbable. Perhaps many fail at the very beginning. Perhaps almost none pass some later threshold. And if so, the silence becomes less mysterious, because very few ever make it far enough to be visible. There are two broad ways to imagine the filter: behind us, or ahead of us. This distinction matters deeply. If the filter is behind us, then humanity may already have passed the hardest steps. Perhaps life itself is extraordinarily rare, or complex cells almost never arise, or intelligence is a profound evolutionary accident. In that case, we may be rare, but fortunate. The silence would reflect hurdles already crossed. That possibility can feel strangely hopeful. It means the dangerous bottleneck may lie in deep history. But there is another possibility. The filter lies ahead. This is the more troubling version. It means many civilizations may reach something like our stage, but almost none continue much further. Something stops them. This something is often discussed carefully and abstractly, because the hypothesis is probabilistic, not a prediction of doom. But it raises questions. Do technological societies tend to destabilize themselves? Do they encounter ecological limits, resource exhaustion, catastrophic conflict, some other bottleneck not yet understood? The details are speculative. The structure is what matters. Somewhere, perhaps, civilizations tend to fail. This idea connects directly to the Fermi Paradox. If advanced civilizations were easy to become, perhaps the galaxy would show more obvious signs of them. Since we do not see that, perhaps some filter suppresses the outcome. Again, it is an argument from silence, but a structured one. It also echoes something from the Drake equation, the longevity term. How long civilizations endure may matter enormously. Perhaps the filter is not at origin, but at persistence. Not becoming intelligent, remaining stable. That shifts the puzzle from biology toward civilizational durability. Some thinkers call these existential risks, risks that threaten long-term survival of civilization itself. In this framing, the Great Filter is not one event necessarily. It could be a pattern, a stage many fail to navigate. There is a quiet irony here. Discovering simple extraterrestrial life might seem like joyful news, and it would be extraordinary. Yet in one interpretation, it could sharpen concern. Because if life begins easily elsewhere, perhaps the hardest filter is not behind us after all. Wikipedia 1. This idea has often been called the unsettling inversion. Good news can carry difficult implications. Though even here, caution matters. These are philosophical consequences of uncertain models, not established conclusions. Science has not located a filter. It has proposed a framework. And frameworks help us think. Some discussions use a ladder image. Many rungs, many chances to fall away. Perhaps reproductive molecules are rare. Perhaps eukaryotic cells are rare. Perhaps tool-using intelligence is rare. Perhaps interstellar expansion is the rarest step of all. The filter could be concentrated at one stage, or distributed across several. Many small improbabilities can act like one great improbability. This resembles what we saw with rare Earth, but now extended beyond planetary conditions. It includes history, evolution, society, technology. A very broad lens. There is also an emotional reason the idea resonates. It turns the cosmic silence into a mirror. Not only asking where others are, but asking what futures are fragile. It makes the paradox personal. Yet, it should not be dramatized too much. The Great Filter is often discussed in dark tones, but scientifically, it is a reasoning tool, not prophecy. It can even be used optimistically. If we identify vulnerabilities, perhaps they can be navigated. A filter need not imply inevitability, only difficulty. Difficulty can sometimes be overcome. Some researchers have tried to think statistically about where filters might lie. Others challenge whether the concept is too broad. That debate is healthy. It reminds us the hypothesis is exploratory. Still, its power comes from a very simple insight. If the universe contains immense opportunity for life, and yet we see no vast civilizations, perhaps some step from matter to cosmic presence is much harder than it seems. That is the core idea. Sometimes people imagine the filter as catastrophe alone. but it could also be stagnation. A civilization may plateau, turn inward, lose expansionary momentum, never become visible across the stars. Silence need not come only from destruction. It may come from limits. That broadens the idea further. There is something almost mathematical about it. Given enough steps, one very improbable step may dominate the whole path. A chain can be limited by one weak link. This returns us again to probability. Quietly. The Fermi Paradox often circles back to probability. Not because probability gives certainty, but because it helps frame vast unknowns. And perhaps that is what the great filter does best. It reframes absence as evidence about difficulty. Not direct evidence, suggestive evidence. Some people find the idea sobering. Others find it motivating. If civilizations may fail, perhaps longevity itself becomes a worthy project. A scientific and ethical project. There is also a gentler reading. Perhaps the filter is simply the extraordinary difficulty of becoming a spacefaring civilization at all. Not catastrophe, just immense challenge. Interstellar expansion may be harder than many assumptions suggest. If so, silence could follow naturally. Again, many possibilities remain open. But one thought lingers. If the hardest step lies ahead, then the cosmic question folds into a human one. Can intelligence persist? Can civilizations mature? These are no longer only astronomical questions. They touch philosophy, history, futures. And yet even the great filter may not explain the silence fully. There is another possibility. Perhaps others are there. Perhaps civilizations exist. And perhaps the problem is not rarity or extinction at all. Perhaps we simply do not yet know how to notice them. Perhaps the silence does not mean emptiness. Perhaps it means limitation. Not their limitation, ours. This is another possibility in the Fermi Paradox. Maybe others exist. Maybe civilizations endure. And perhaps we simply do not yet know how to detect them. This idea begins with humility. We may be searching in very narrow ways. Consider how young our search has been. Serious modern SETI efforts span only decades. A small moment in cosmic time. We may be like listeners who have just arrived, tuning a few frequencies in a vast electromagnetic ocean. Silence under such conditions may tell us little. For a long time, people imagined alien detection mainly as radio signals. A narrowband transmission. A deliberate beacon. This remains part of SETI. But the search has broadened. SETI Institute 1. Scientists now speak often of technosignatures, signs of technology. not necessarily messages, just evidence that technology exists. A signal is one kind, but there may be others. Unusual infrared waste heat has been discussed. Large-scale engineering has been imagined. Atmospheric industrial traces have been considered. NASA Science 2. The important point is simple. We may have been searching too narrowly. If intelligence expresses itself in unfamiliar ways, our assumptions could hide it from us. This is sometimes called an anthropocentric bias. We imagine others might resemble us. But why should they? Different biology may produce different technologies. Different histories may produce different priorities. Perhaps advanced civilizations do not broadcast loudly. Perhaps they communicate in ways we do not yet recognize. Or perhaps they have little interest in leakage at all. Human radio leakage itself may be brief in historical terms. Some have even argued our detectable radio signature may shrink as communications evolve. If detectable phases are short, overlap becomes difficult. Arc-Civ 3. Again, timing returns. Quietly. But there is another limitation. Distance. Space is immense. Signals weaken. Even powerful transmissions may fade into background noise over interstellar distances. We often imagine listening everywhere. In truth, we have sampled tiny regions, tiny frequency slices, tiny windows in time. Some researchers compare the searched fraction to scooping a cup from the ocean, perhaps even less. In that light, non-detection may not be surprising. It may simply reflect incomplete search. There is a phrase sometimes used, the search space. It means all combinations of frequency, location, time, signal type, modulation, and more. It is enormous, much larger than intuition suggests. We may have explored only a thin corner. That alone can soften the paradox. Silence may be less mysterious when listening is so partial. There is also the possibility we may be overlooking signals already present. Not because they are obvious, but because distinguishing artificial from natural phenomena can be hard. Astronomy is full of anomalies later understood naturally. Caution is necessary. Yet it also means recognition may be difficult even when something unusual appears. Modern searches increasingly use machine learning for anomaly detection, Nature 4. That itself says something important. We may need better ways to notice what we do not expect. There is a quieter possibility, too. Advanced civilizations may be efficient rather than conspicuous. We often assume advancement means bigger, louder, brighter. But perhaps maturity means subtlety. Lower waste, less leakage, more inward focus. In that case, visibility may decrease with advancement. A strange inversion. The more advanced they become, the harder they are to notice. That possibility has been explored seriously. not as fact, as possibility. Then there is the issue of signal intent. We often imagine deliberate contact. But why assume others wish to announce themselves, or that they do so continuously? A beacon may be intermittent, directional, rarely pointed our way. We may simply not be in its path. Even Earth illustrates detectability limits. Studies have modeled how far some present-day human technosignatures might be noticed. Results vary by signal type. Some may be detectable much farther than others. SETI Institute, 5. The lesson is not that Earth is easy to detect, but that detectability is complicated. That complication may apply universally. Sometimes people ask, why do we not see giant alien megastructures? But this assumes civilizations pursue such paths. We do not know that. It may be projecting human speculation outward. Again, the theme returns. Perhaps assumptions hide possibilities. There is also a deeper epistemic problem. We may not know what unfamiliar intelligence looks like from afar. We search partly using examples drawn from ourselves, but one example can be a narrow guide. Some call this the problem of unknown unknowns. Signals we do not know to search for. That is a quiet but profound limitation. And yet, despite these limits, the search continues becoming broader. Radio searches continue. Optical searches continue. Technosignature ideas diversify. SETI Institute, 1. Not because evidence of others has been found, but because the search itself is still very young. There is patience in that. Scientific patience. It may help to imagine early ocean exploration. A few coastlines mapped. Vast waters unknown. One would not conclude the ocean empty because one voyage returned without whales. This analogy has limits, but the intuition helps. Non-detection can reflect search immaturity. Some even argue the Fermi Paradox may overstate silence. Because we have found nothing can sound stronger than reality. More precisely, we have not yet confirmed technosignatures despite limited searches. That is a softer claim, and perhaps a more accurate one. There is something calming in this perspective. The universe may not be refusing to answer. We may still be learning how to ask. Sometimes that is the deeper scientific story. Of course, this explanation does not prove civilizations exist. It only shows silence may be less decisive than it appears. The paradox may partly reflect observational limits. Perhaps we are early. Perhaps under-equipped. Perhaps conceptually narrow. All are possible. And notice how this differs from rare earth or the great filter. Those explain silence through rarity. This explains silence through perception. Not absence, hiddenness. That is a very different kind of answer. It also leads naturally to stranger ideas. If others exist yet remain undetected, is it because we miss them accidentally? Or because some choose not to be seen? That thought opens another branch of the mystery, one where silence may not be passive at all, but intentional. Perhaps the silence is not accidental. Perhaps it is chosen. This is where the Fermi Paradox moves from limits of detection into more speculative territory. Still logical, still structured, but more speculative. Two famous ideas live here: the zoo hypothesis and the dark forest. They are very different ideas, but both begin with a shared thought. Civilizations may exist, yet remain silent on purpose. Begin with the zoo hypothesis. It proposes that advanced civilizations might avoid contacting emerging civilizations like ours. n.wikipedia.org https://n.wikipedia.org/wiki/zoo_hypothesis?UTM_source =chatgpt.com. As though preserving natural development, observing without interference. The analogy of a zoo is imperfect. Sometimes a wilderness preserve is a gentler analogy. The core thought is non-intervention. Why might such a policy exist? Some have imagined ethical reasons. Perhaps advanced beings adopt principles against disrupting less developed societies. A kind of cosmic restraint. Others imagine practical reasons. Contact could be destabilizing, misunderstood, harmful. Better to wait. This idea has appeared in scientific and philosophical discussion for decades. Not as established theory, as one speculative resolution of the paradox. If true, silence would be deliberate, not absence. But there are difficulties. The hypothesis may require many civilizations sharing similar restraint. That can seem demanding. Why would all, or nearly all, cooperate? This is sometimes called the coordination problem. A single dissenting civilization could break the quiet. Unless only very few civilizations exist, or one dominant culture shapes behavior. Again, speculation. But structured speculation. The zoo idea is not about hiding necessarily. It is about withholding contact. That distinction matters. It imagines the silence as ethical silence, or perhaps observational silence. A universe not empty, but quiet around developing worlds. There is something almost anthropological about it. It mirrors human questions about interference and autonomy. Whether such principles scale cosmically, we do not know. But the thought has endured. Now consider a much darker possibility. The dark forest. Popularized widely through The Dark Forest, though related strategic ideas appear in broader discussion. The metaphor is simple. Imagine a dark forest at night. Every creature moves cautiously, hidden, unsure of others' intentions. In such a forest, calling out may be dangerous. Applied cosmically, the thought is this: civilizations remain silent because revealing one's location may invite threat. Silence becomes survival strategy. The reasoning usually rests on uncertainty. You may not know whether another civilization is benevolent or hostile. And across vast timescales, intentions may change. If stakes are existential, caution may dominate. This is less ethical than the zoo, more strategic. Silence not from protection of others, but protection of self. It is important to note this is highly speculative. It is not a scientific consensus. Many criticize it. Some argue it assumes too much conflict. Others note interstellar hostility may be far less practical than fiction suggests. Distances alone complicate many simple scenarios enormously. Yet, as a philosophical response to the paradox, it remains influential because it gives silence a motive. There is also a game-theoretic flavor here. If everyone fears exposure, mutual silence may emerge, even without anyone wishing isolation. A coordination outcome, an equilibrium of caution. Whether realistic or not, the logic has a certain austere coherence. Some discussions connect this to debates about METI, messaging extraterrestrial intelligence. Should humanity actively transmit powerful, deliberate messages? Some argue yes, as curiosity, as outreach. Others urge caution. The dark forest idea partly informs that caution in popular discussion. Though many scientists consider catastrophic fears speculative and uncertain, again, careful balance matters. Interesting idea, not settled doctrine. There is a subtle contrast between these two hypotheses. The zoo says they may be silent because they care. The dark forest says they may be silent because they fear. Care, fear. Two very different logics producing the same outward phenomenon. Silence. That alone is fascinating. One observation. Multiple explanations. A common feature in science. There are softer variants too. Some imagine civilizations may simply prefer low observability. Not because of danger, not because of ethics, just because expansion and contact may not be compelling goals. Again, silence, for another reason entirely. This shows how broad intentional silence ideas can be. They need not all be dramatic. Sometimes critics say these ideas feel too anthropomorphic, too much like projecting human motives into the stars. That criticism has force. It should be taken seriously. Yet projection is hard to avoid when reasoning from one example of intelligence. We begin with ourselves because we have little else. Carefully, Another criticism is evidential weakness. These ideas can explain silence after the fact, but may be difficult to test. That makes them philosophically interesting, but scientifically constrained. This too matters. Speculation should know it is speculation. And yet such ideas endure because they reveal something about the paradox itself. The silence is compatible with many stories. Rarity, filters, detection limits, intentional quiet. The same observation branches outward. There is something almost elegant in that branching. A simple question generating many explanatory worlds. It also shifts the emotional texture of the mystery. Earlier sections asked whether others exist. Here, the question becomes how civilizations might behave. A different kind of speculation, more sociological in a cosmic sense. And perhaps that is why people remember these hypotheses. They feel like thought experiments about intelligence itself. How does intelligence act under uncertainty? With restraint? With caution? With concealment? Even if the answers remain unknown, the questions linger. It is worth remembering, too, that silence need not have one universal cause. Perhaps different civilizations, if they exist, behave differently. Some quiet, some detectable, some gone. Reality could be messier than any single hypothesis. That often proves true in science. Nature resists neat categories. And still the mind wanders further. If silence may hide civilizations, perhaps stranger possibilities remain. Civilizations expanding as great waves. Civilizations turning inward into virtual worlds. Civilizations waiting for distant cosmic eras. Stranger possibilities, yes, but still attempts to answer one old quiet question. Where is everybody? Or perhaps more carefully now, in what unexpected ways might they be present? Beyond the better-known explanations of the Fermi Paradox, there are stranger possibilities. Speculative, yes, but often logically motivated. They ask whether the silence may come not from absence, nor catastrophe, nor concealment alone, but from forms of civilization we scarcely imagine. Some of these ideas sound unusual at first, yet each begins with a serious question. What if advanced intelligence behaves in ways very unlike our intuitions? Consider first a modern thought experiment, sometimes called grabby aliens, associated especially with Robin Hanson and collaborators. ResearchGate 1. The name sounds playful. The idea is not. It begins with a puzzle about timing. Humanity may appear surprisingly early in cosmic history. Our universe is around 13.8 billion years old. Yet many stars, especially smaller red dwarfs, may persist vastly longer. Trillions of years, perhaps. If life and intelligence can arise across that enormous future, why do we seem so early? One proposed answer is this: some civilizations, once advanced enough, may expand outward persistently. Not all civilizations, a subset. Those that do might gradually occupy large regions, altering environments as they spread. In this model, such expansion creates a kind of deadline. Civilizations like ours tend to appear before expanding waves reach them. That could help explain why we find ourselves early. There is a subtle twist. The model can suggest we do not see such civilizations nearby precisely because observers like us arise in regions not yet reached. ResearchGate 1. A selection effect. Not obvious at first. This is not a claim that invisible empires surround us. It is a probabilistic thought experiment. It has critics. Many assumptions are debated. But it is interesting because it reframes silence through expansion dynamics. Notice how different this is from the Great Filter. The Great Filter emphasizes bottlenecks. Grabby aliens emphasize expansion and timing. Different logic. Same mystery. There is something almost ecological about it. Life filling niches at cosmic scale. Yet perhaps expansion is not the destiny of advanced civilizations at all. Some thinkers imagine nearly the opposite. Civilizations turning inward rather than outward. Not colonizing stars, but immersing themselves in virtual or computational worlds. This sometimes appears in discussions of post-biological futures. A civilization may find richer possibilities inward than among the stars. If so, outward visibility may be low. Silence again. But for another reason. This possibility has a quiet elegance. We often assume advanced means expansive. But perhaps advanced means efficient, miniaturized, inward. Perhaps the grand galactic empire is a human projection. We do not know, but the question matters. Then there is one of the strangest ideas of all. The aestivation hypothesis. From the word aestivate, to become dormant during heat, analogous to hibernation in cold. Proposed by Anders Sandberg, Stuart Armstrong, and Milan Ćirković, RxEve 2. The thought is unusual. Suppose a highly advanced civilization seeks to maximize future computation. Some argued that waiting for a much colder future universe could make energy resources more useful for certain computational purposes. In that case, a civilization might remain largely inactive now, conserving resources, waiting. Silence, then, not from extinction, but patience. It sounds almost dreamlike, yet it arose from physics reasoning. Importantly, it has also been criticized. Some researchers argued the computational advantage may be overstated, RxEve 3. That matters. This is not accepted resolution. But as thought experiment, it is striking. Imagine civilizations sleeping through cosmic ages. Not dead, waiting. a quiet answer to a quiet universe. These ideas share something important. They challenge a simple assumption that advanced civilizations would be obvious. Maybe they expand in ways we do not expect, or turn inward, or wait. Different futures imply different signatures. Sometimes these possibilities are grouped loosely under "they may be stranger than we assume." And perhaps that is the common theme. Our imagination may be provincial, earthbound. We extrapolate from a young civilization barely beyond its cradle. That may be a narrow vantage. There are other speculative ideas too. Some imagine civilizations dispersing into forms difficult to recognize. Some imagine motives we cannot model well. But one must be careful. Speculation can drift untethered. Better to keep returning to disciplined questions. What assumptions are being challenged? What problem is being addressed? In that spirit, these ideas each address a version of visibility. If others exist, why do we not notice them? Grubby aliens answer through selection and expansion. Inward civilizations answer through low outward expression. Aestivation answers through deferred activity. Three very different logics. There is something calming in noticing that. The mystery need not force one explanation. It opens many. And yet some philosophers take another step back entirely. They ask whether perhaps the Fermi Paradox itself may be overstated. Perhaps silence is not truly paradoxical, only made to seem so by uncertain assumptions. Before turning there, one more reflection. These stranger hypotheses often reveal as much about us as about aliens. Our ideas about expansion reflect our history. Our ideas about inward virtuality reflect our technologies. Our ideas about waiting reflect our philosophies of time. We project, inevitably. Carefully, one hopes. This does not make the ideas empty. It makes them mirrors as well as models. That can be valuable. There is also a gentle pattern emerging through all these sections. First, we imagined life rare. Then civilizations filtered. Then hidden by our poor detection. Then silent by choice. Now stranger civilizational futures. Each possibility preserves the central question while reshaping its answer. And perhaps that is what makes the Fermi Paradox endure. It is less one puzzle than a crossroads of puzzles. Every answer leads sideways, quietly. Some listeners may feel these later ideas drift far from science. That concern is reasonable. But there is value in boundary cases. They test assumptions. Even rejected ideas can clarify thinking. For example, asking whether civilizations might turn inward forces us to ask why we assume expansion. Asking whether they might wait forces us to ask what advanced goals could be. Questions can illuminate even without final answers. And still, after all these possibilities, a quieter possibility remains. Maybe the mystery partly comes from the word paradox itself. Perhaps there is no true contradiction, only uncertainty wearing the costume of paradox. That thought leads to another kind of resolution, one that does not explain where everybody is, but questions whether we were justified expecting everybody at all. At this point, a quiet possibility begins to emerge. Perhaps the Fermi Paradox is not entirely a paradox. Perhaps part of the mystery comes from expectations that may be too strong. This is a subtler resolution, not an explanation of where civilizations are, but a question about whether their absence is actually surprising. To feel a paradox, we must first feel a contradiction. We expect many civilizations, yet we see none. But what if the expectation itself is fragile? This thought has been raised by many scientists and philosophers in different forms. Sometimes the paradox may depend heavily on optimistic assumptions. Assumptions about life emerging often, about intelligence being common, about expansion being likely, about detectability being easy. If several of those assumptions weaken, the contradiction may soften, perhaps even dissolve. Consider the original intuition. Given enough time, a civilization could spread across the galaxy. This is often presented as almost inevitable. But is it? Some scholars have questioned whether interstellar expansion would actually proceed as simple models assume. The challenge may be much harder. Energy costs, social choices, physical limits. Even if technically possible, inevitability may be too strong a word. If expansion is difficult or unattractive, then the expectation of a visibly colonized galaxy weakens. And with it, the force of the paradox. Likewise with intelligence itself. Sometimes popular discussions slide from many planets exist to many civilizations should exist. But those are very different claims. Between them lie enormous uncertainties. Biology, evolution, history. If those uncertainties are larger than optimistic estimates assume, silence may not be shocking, just unresolved. There is a phrase sometimes used in philosophy of science: underdetermination. It means evidence may support many interpretations. The Fermi Paradox has some of that quality. Silence alone may underdetermine conclusions. It may point to rarity, filters, detection limits, or perhaps simply modest expectations. This does not solve the mystery, but it changes its shape. From contradiction to open problem. Some thinkers go further. They suggest calling it a paradox may overstate tension. Perhaps it is better described as the Fermi question, or Fermi problem. Why no obvious evidence yet? That phrasing feels softer, more scientifically cautious. There is merit in that. Because paradox can imply something logically impossible. But perhaps nothing impossible exists here. Only large uncertainties interacting. Consider also observation bias. We live in one young civilization, with limited data, at one moment in cosmic history. From that narrow perch, how strong should our expectations be? Perhaps not very strong. Humility again enters. This perspective does not deny the fascination of the silence. It only questions whether silence requires dramatic explanation. Sometimes no dramatic explanation is needed. Sometimes uncertainty is enough. There is a kind of intellectual calm in that. Not every mystery conceals catastrophe or profound cosmic secret. Sometimes it reflects incomplete knowledge. That may sound ordinary, but ordinary explanations often deserve respect. In science, the exotic can attract attention. But sometimes the quieter answer is stronger. We may simply know too little. And there is no shame in that. Only frontier. Some critics of the paradox note another subtle point. Even if galactic colonization is possible in principle, one might still reasonably find no visitors here. Because distribution need not be uniform. Timing need not favor us. Assumptions of inevitable visitation may be too simplistic. Again, the contradiction softens. Not disappears entirely, softens. That distinction matters. It is also worth noticing how much the paradox has functioned as a heuristic, a device for generating hypotheses. Even if the paradox is overstated, it has been productive. It pushed thought toward astrobiology, toward SETI, toward thinking about civilizational longevity. Sometimes a question need not be perfectly framed to be fruitful. That too is part of science. Fertile questions matter. There is almost a philosophical reversal here. Instead of asking, "Why is the universe silent?" we ask, "Why did we expect it not to be?" A different question entirely, yet profound. It turns scrutiny onto our assumptions. And assumptions are often where mystery begins. Perhaps the Fermi Paradox teaches caution about extrapolation. One civilization should not too quickly generalize all civilizations. One history should not define cosmic history. One ambition should not define intelligence. These are sober lessons. At times, this softer view can seem less exciting, less dramatic than dark forests or great filters. Perhaps, but not less profound. There is profundity in recognizing uncertainty honestly, and perhaps even beauty, because it preserves openness. The universe remains mysterious without forcing one hidden mechanism behind the mystery. Just spacious uncertainty, vast as the stars. There is another reason this matters. If the paradox partly dissolves, then perhaps we should be careful not to build sweeping philosophical conclusions upon it. For example, claiming humanity must be unique or doomed. Such claims may outrun evidence. A softened paradox invites softer conclusions, provisional ones. Science often prefers provisional conclusions, quietly. And after all, we are still early in exoplanet science, early in biosignature science, very early in technosignature science. The story may look different in centuries to come, perhaps dramatically different. That possibility alone should temper certainty. In this light, the Fermi Paradox becomes less a problem-demanding solution and more a contemplative framework, a way of organizing possibilities. That may be enough. Not every profound question ends in resolution. Some deepen into perspective. And perhaps this is where the mystery begins turning inward, away from where others are, toward what the silence means for us. Because whether the paradox is sharp contradiction or softened puzzle, it still presses on human self-understanding. What does it mean to be a technological species under silent stars? What responsibilities arise if intelligence is rare or fragile? Those questions remain. Perhaps they matter even more than the paradox itself. And from here, the mystery becomes almost philosophical in the deepest sense. Not merely about extraterrestrials, but about civilization, fragility, and meaning. A final reflection begins there. After moving through probabilities, filters, silences, and speculation, it may be tempting to ask for a final answer. But the Fermi Paradox resists final answers. Perhaps what it offers instead is reflection. Reflection not only about others, but about ourselves. Because whatever the silence means, it changes how we see intelligence. It changes how we see civilization. Suppose intelligent life is rare, very rare. Then conscious beings capable of asking these questions may be uncommon events in the universe. That thought carries weight, quiet weight. Not because rarity implies superiority. It does not. But rarity can imply preciousness. A thing can be ordinary to itself and still cosmically rare. If that were true of intelligence, the silence would not merely be absence. It would frame the fragility of awareness itself. On the other hand, suppose intelligence is common, but civilizations often fail. Then the silence might whisper something about survival. That intelligence alone is not enough. That endurance may be harder. In that case, the paradox becomes almost ethical. What allows a civilization to persist? Wisdom? Restraint? Cooperation? Perhaps such questions matter whether or not the great filter is real. Because they are human questions too. Quietly practical questions. There is another possibility. Perhaps others exist, and the silence reflects our youth. We may simply be early listeners. If so, the paradox can evoke humility. We may be beginners in a much larger story. Humility can be a scientific virtue. It keeps wonder open. But beyond which hypothesis is true, something deeper may remain. The paradox forces us to ask what intelligence is for. That is a large question, larger than astronomy. Is intelligence simply adaptation, a survival tool? Or does reflective awareness carry responsibilities? Such thoughts arise naturally when considering civilizations over cosmic time. Because cosmic time makes ordinary concerns look small. Borders, eras, empires. They shrink under stars. The paradox can have this effect. It can reorder scale in the mind. 100 years feels brief. 1,000,000 years feels imaginable, if only dimly. Civilizations begin to look like processes, not permanent structures. That perspective can be strangely calming. It can also sharpen appreciation of Earth. Whatever the universe contains, this world is one confirmed oasis of life. Oceans moving under moonlight, forests breathing, minds wondering. These are not abstractions. Sometimes discussions of extraterrestrial life become so large they eclipse the near miracle of the living world already here. The paradox can reverse that. It can make the familiar feel astonishing again. There is also a quiet loneliness some people feel in this subject. What if we are alone? It can sound bleak. Yet some philosophers have argued the thought can also deepen meaning. If intelligence is rare, then preserving and enriching it matters greatly. A lonely universe could make care more urgent, not less. And if we are not alone, then we participate in a wider story than we yet perceive. Either possibility invites awe, different kinds of awe. That symmetry is beautiful. The silence also raises questions about contact that are less technological than philosophical. What would it mean to meet another intelligence? Would the deepest discovery be biological or conceptual? To know thought arose twice in one universe. That alone would change human self-understanding. Even without contact, the possibility already does. In that sense, the Fermi Paradox is partly a mirror. We ask where others are, and end up asking who we are. That is why the question endures beyond technical astronomy. It reaches into philosophy because it touches identity. What is a civilization? What makes one durable? What makes intelligence wise? These are not separate from the paradox. They emerge from it. There is a thought sometimes expressed in astrobiology. That life may be the universe becoming aware of itself. It is poetic language, but it gestures towards something real. Conscious beings are places where matter reflects. If such places are rare, rarity matters. If they are common, then perhaps reflection fills the cosmos quietly. We do not know which, but both thoughts enlarge perspective. There is also a lesson about uncertainty itself. The paradox has many proposed resolutions. Rare Earth, great filters, detection limits, intentional silence. Yet none is decisive. And still inquiry continues. This, too, is part of science. Living with unresolved questions, not as failure, as frontier. There is dignity in that. Sometimes unresolved questions are the ones that mature thought most deeply, because they resist quick closure. The Fermi Paradox may be such a question. It can make one think about long futures, not only whether humanity survives, but what surviving well might mean. Perhaps becoming the kind of civilization that lasts. That phrase has a quiet gravity. A civilization that lasts. Not merely technologically powerful, but enduring. There is a difference. And perhaps that is one of the deepest human lessons drawn from the silence. That persistence may be more profound than expansion, more meaningful than conquest. Even the possibility of being early in cosmic history can inspire a kind of responsibility. If intelligence is young in us, perhaps what it becomes matters. Not because the cosmos asks it, but because we do. Some people hear in the great silence only emptiness. Others hear invitation. Invitation to listen longer, to think wider, to care more carefully for a living world. Perhaps all are present. There is something fitting that a question born over lunch could lead here. From a casual remark to reflections on civilization and cosmic meaning. It shows how simple questions sometimes contain enormous depth. Where is everybody? Perhaps the power of the question lies partly in never being finished. It remains open enough to keep enlarging thought. And now, after theories and possibilities, perhaps it is enough to return once more to the night sky itself. To the quiet stars, the ancient darkness between them. And to rest for a moment in the mystery, not as a problem to solve, but as a silence to contemplate. From there, one final step remains. Not toward an answer, but toward simply drifting beneath the great silence itself. Now the question can be allowed to soften. Not solved, not concluded, softened. Because perhaps some mysteries are not diminished by remaining open. They deepen. We began with a simple question. If the universe is so vast, where is everybody? A question first spoken almost casually, yet carrying the weight of cosmic silence. And through many possible answers, no final answer arrived. Only possibilities, carefully considered. Life may be rare. Civilizations may struggle to endure. We may be listening too narrowly. Others may remain silent intentionally. Or perhaps the mystery partly arose from expectations themselves. All remain open, quietly open. And perhaps that openness is fitting. Because the universe itself often exceeds closure. The night sky does not explain itself all at once. It invites patience. Perhaps the Fermi Paradox does too. Imagine for a moment the long age of the stars. Light leaving distant suns long before human history. Crossing darkness for centuries, millennia, longer. Reaching telescopes built by creatures on one small world. There is something gentle in that image. Light arriving without speaking. Presence without explanation. Perhaps the great silence feels like that. Not empty exactly. More like a question held open by distance. Sometimes we imagine silence as absence. But silence can also be fullness beyond hearing. A forest at night can seem silent, while filled with life too subtle to notice. The analogy is imperfect, yet soothing. We do not know whether the universe is empty of others, or quietly alive beyond present reach. Both remain possible. There is humility in leaving both open. And perhaps humility is one of the deepest moods this mystery offers. Humility before scale, before time, before unknowns. In an age of fast conclusions, there is something restorative in a question that resists them. A question one can simply dwell with. If intelligence is rare, then every conscious world may be precious. If intelligence is widespread, then perhaps the cosmos is richer than we yet know. Either possibility carries wonder, quiet wonder. Perhaps that is enough. Not every mystery exists to be conquered. Some exist to enlarge perception. The Fermi Paradox may be one of these. It stretches thought across billions of years, across galaxies, then returns gently to one fragile world, to oceans, to atmosphere, to minds awake beneath stars. There is a quiet circularity there. The farther outward the question reaches, the more intimately it returns home. Perhaps that is why the paradox lingers. It is cosmic in scale, but personal in feeling. Even as a sleep story, it carries something almost meditative. A rhythm of question, possibility, uncertainty return. And now perhaps the mind can loosen its grip on solving. Simply drift among possibilities. Imagine ancient civilizations rising around distant suns, or none at all. Imagine quiet worlds of microbes beneath frozen oceans. Imagine silent telescopes listening across interstellar dark. Imagine future generations knowing more than we do, or still wondering. All these belong to the mystery. Sometimes people ask whether the Fermi Paradox will ever be solved. Perhaps partly. Perhaps through biosignatures, through technosignatures, through discoveries not yet imagined. Or perhaps it will slowly dissolve, not through one revelation, but through accumulated understanding. That is often how science moves. Not thunder, dawn, a gradual brightening. Until then, silence remains part of the story. But perhaps no longer as something unsettling, more as something spacious, a room thought can inhabit. There is a beautiful restraint in admitting we do not know. It leaves wonder alive. And maybe wonder is itself part of intelligence at its best. Not only solving, also contemplating. Not only mastering, also listening. Listening, perhaps, is where we began. Radio dishes turned toward stars. Minds asking into silence. There is something deeply human in that. Asking, though answers may not come soon. Curiosity enduring uncertainty. Perhaps that is its own quiet triumph. That a species can arise, look into darkness, and ask who else may be looking back. Even unanswered, it is remarkable. And now the question itself can begin to dissolve into atmosphere, into stars overhead, into slow-turning galaxies imagined beyond sleep. No need to decide tonight whether the silence means rarity, or hidden neighbors, or only our early ignorance. Let them remain possibilities. Let the mind rest in their spaciousness. Perhaps somewhere, around some distant star, other minds have asked their own version of this question. Perhaps not. We do not know. But the not knowing need not feel cold. It can feel vast, gentle, like standing beneath a clear winter sky where stars seem almost motionless. Yet all is moving, quietly. Galaxies turning, light traveling, worlds orbiting unseen suns. Whether inhabited or not, the universe continues in silent magnificence. And perhaps that alone is enough for wonder before sleep. The old question fades a little now. Where is everybody? Maybe tonight it becomes something softer. What kind of universe gives rise to beings who can ask it all? A different mystery, equally deep. Let that question drift outward, past the moon, past the planets, past the edge of the Milky Way, into the dark between galaxies. And let the great silence be not an emptiness, but a vast stillness in which thought can slowly fall asleep.